everybody. Welcome to this week's asynchronous class. We're at a really cool point in the semester. I always love this point of the semester, and here's why. First, you came in here with a really strong foundation in explicit instruction. So you know explicit instruction. You know it as I do, we do, you do, but it's also known as model lead test. So if you see that anywhere, it's the same thing. Model lead test, I do, we do, you do, exact same. But you came in here with a strong foundation in explicit instruction, which is an evidence-based practice for our population, right? For students with complex support needs. Not only that, you've learned about systematic instruction. And I do want to take a second to, have you reflect on what your part in systematic instruction is. So we know things like when we are implementing or planning systematic instruction, that we are intentionally planning that instruction, that we are breaking complex tasks into smaller teachable steps that are more manageable for our students and that lead to quicker acquisition of skills. We know that we then sequence those skills in a logical order, that we teach foundational skills before we teach more advanced or complex skills. Things like we don't teach similar skills at the same time, or things like again, we teach things in a logical order so that we then are leading, we're teaching, we're building on the skills that the students know, we're accessing their prior knowledge, we're making database decisions. So we know all those kinds of things, but I don't want you to think that that is outside of you. Because as a teacher, when I think about systematic instruction, I think about myself as the system that makes systematic instruction work. If it's not for you, systematic instruction never would occur. It is only because you, the teacher, that systematic instruction happens in your classroom. And that means that you are intentionally planning your lessons. You are looking at your lesson and you are planning them in a specific order. You know what's going to happen first, what's going to happen second, what's going to happen third, and that those skills are building on one another. You know, when you're doing things like implementing a prompting hierarchy, for example, that you are systematically implementing it. You are following it as written, as predetermined. We don't add anything to it. We don't take anything away. We don't repeat prompts when it's time to move to the next least intrusive prompt. And so I really want to caution you about adding things specifically is something that I've seen to your prompting, such as a verbal prompt. Is it okay to have a gesture and a verbal prompt together? Absolutely, if it's in your prompting hierarchy. However, if your prompting hierarchy says that you have a gesture and you add that verbal prompt to it, you have just made that prompt more intrusive. So you want to very systematically implement it, following the prompting hierarchy as determined and following it in order. Same thing with the task analysis. You are going to write your task analysis so that those manageable steps are individualized for your student. So you want to follow it very systematically. And again, you have to be the one who is making sure that that instruction is systematic. So again, you've got that systematic instruction, really, really powerful, powerful method of teaching. You have learned about stimulus prompting. You've developed a plan, you've developed a fading plan. Excellent skill to have. Not only that, you have learned 5 response prompting strategies. So system of least prompts, time delay, most to least prompting, graduated guidance, and simultaneous prompting. Did you know that if you take those 5 instructional strategies, response prompting strategies, which are evidence-based practices or at least research practices for a whole plethora of skills, and you take that in explicit instruction, you can teach anything. You can teach academics, you can teach social skills, you can teach vocational skills, you can teach language and communication. For our students with complex support needs, you can teach anything. Not only that, you've also learned about universal design for learning, which is all about access. So now not only can you teach anything, but you can make that learning accessible for any student, with or without a disability. So I want you to stop and think about that. You now have the skills to teach any you have the skills and the knowledge to teach any skill in any context to any age student who has an intellectual disability, autism, traumatic brain injury, developmental disability, multiple disabilities, and you can make that learning accessible to anyone. Think about how powerful that is. Think about how powerful those skills and that knowledge is. And now I want you to stop and think that you possess that. And so think how powerful you are. Seriously, think how powerful you are. You have the skills to change children's lives. And not only when you have them, not only while they're in school, but for the rest of their lives. And so that to me is very exciting. And I'm really proud of the progress you all have made so far. And so what we're going to do now, starting this week, is we're going to take these amazing skills that you have and this awesome knowledge, and we're going to start integrating it into academic content areas. And we're going to start with math, and specifically, we're going to look at early numeracy. But before we do, I want us to look at what you have coming up. These dates are only for the current cohort. So it is important that it is your responsibility that you look on Canvas and that you look at your syllabus to see what dates are correct for your cohort. And so, coming up next week, obviously, you have your discussion guide due. You have a quiz on universal design for learning that's coming up that mirrors the one on systematic instruction. You also have a lesson plan coming up, and this does not look like the explicit instruction lesson plan. It is nowhere near that in depth. But you are going to teach two math lessons. This is going to be math lesson 1, and you are going to teach some type of a math skill in a one-on-one instructional arrangement. We're doing early numeracy this week. If you can teach early numeracy, that's fantastic. If that does not fit your student, you teach whatever you want. We are going to have a mid-course evaluation that will be coming up next week, and I am going to share that in class is when I'm going to share that. So I'm going to give you time to complete that in class in week 7. All right, and in week 7, we're going to continue to do early numeracy, but we're going to really do a focus on word problems. So again, make sure you look at the dates for your cohort. This is what you have coming up next week. As always, you can look at Canvas, has your in our modules, we have all of the information that you need. All of your assignments are listed, and you can also look at your syllabus. Here are your learning objectives should you desire to review them. All right, so let's get ready to jump into this week's content. We're going to start with question 1, and our procedure from here on out is that you are going to number your questions. So that's how I know if you answered them all as well, but it helps me to track them. So this is question number 1 for this week, and what you're going to do is write a question, or at least enough of the question that I know what the question was, and then you're going to skip down to the next line, and that's what you're going to write your answer, where you're going to write your answer. If there are bullet points, do a different line for each bullet point. So question number 1 for this week, what percentages of students, and this is going to be in the year 2022 and 2023, took the alternate assessment here in Utah? So what percentage of students who took the alternate assessment in 2022, 2023 in Utah do you think tested proficient in math? So what percentages of students in 4th grade, 8th grade, and then in high school, specifically 9th and 10th grade, do you think tested proficient in math on the alternate assessment? So what I want you to do is I want you to stop the video, then come back and we'll compare your estimations to the actual numbers. All right, go ahead and stop your video now. All right, now that you have guessed, put in a guess or an estimation or predicted what you think the numbers will be, let's look at the actual numbers. So between 1.7 and, between 0.7 and 0.75 students in Utah in grades 3 through high school took the alternate assessment in math and in reading. And when you put all of it together, remember that the students who take the alternate assessment are typically between around 1%. That is what is allowed on the national average that's allowed. We typically run about 1.1% of our student population. And so we're going to start by looking at reading. Because I had access to reading and math, I thought we would compare them to see what the difference is. So we're going to start with reading, not math. So in grade 4, you can see how many students tested, 462, and only 54 were proficient in reading. That's 11.5%. I mean, 11.7%. I don't know about you, but that's a bit shocking, right? Only 11.7% of our students with complex support needs who are students who take the alternate assessment are proficient. In eighth grade, it is 21.7%. You can see the numbers there in front of you. In high school, it's 27.6%. So what you can see is that in reading, students' reading skills increased over time, right? From 11, almost 12 to almost 22 to almost 28. So now let's look at math, and then I want you to compare yours to our math scores. So in Utah in 2000, oh, that's not 23, it's 22, 24. I tried to find 23 and 24 and could not. So in 22, 23, you can see that in elementary school, 30.7% of our students were proficient in math in fourth grade. Now that sounds exciting because reading was only 11.7. But I want you to look at the opposite side of that. That also means that 69.3% of our students in fourth grade are not proficient in math. 69.3% are not proficient. Let's look at eighth grade. Eighth grade is only 8.3%. Look at that drop. 458 students were tested and only 38 were proficient in math. And then when we look at high school, we can look at it was 14.2%. Again, 14.2%. So out of 890 students, 123 students were proficient. So why do you think that when we looked at math reading that the students' scores got higher as they went along in school up through high school, but in math the scores go down. The scores go down. So I want you to think about that, and that will be question number 2. Why do you think the scores in reading, in reading increase across grades, but the scores in math decrease across grades? So that's question number 2, okay? And this is what I think when I see that. Wait, what? What? Are you joking? Not only that, and I looked to see if there were any more recent data on this, although the percentages have not changed a lot. I mean, we just saw math, right? We just saw what math looks like. But I did want to share this with you because this is shocking. And again, it is not the data would not look much different these days. But in 2009, Toll Reeves et al., and then in 2011, Kearns et al. Looked at math skills specifically. And they wanted to look at individual math skills and see where are students with moderate and severe disabilities, where are they proficient? What does that data look like? And so when they looked at math by matching 1 to 1 up to 10, so that's 1-to-1 correspondence up to 10, just counting, not telling how many is in a set. In 2009, 23% of students with moderate to severe disabilities were proficient. Then in 2011, it was 31%. And again, that was because there was an increase in research between those two. And while we've had an increase in research, we can tell by our math scores that there's not been a huge increase. Although we don't have it broken down, we just looked at our state overall percentages, right? So when we look at rote counting to 5, 1, 2, 3, 4, 5, in 2009, 7.7% of students were able to count to 5, and in 2011, it was 12%. Shocking, to count to 5. When we look at applying computation in everyday problems, that could be addition, it could be subtraction, it could be multiplication. In 2009, it was only 3.3%, and by 2011, it had only risen to 4%. Now, Kearns et al. Did another measure, and that was looking at no observable awareness or use of numbers. And between 12 and 17% of students with moderate to severe disabilities have no awareness of use of numbers. And so what does this tell us? And what it tells us is that the majority of students with moderate to severe intellectual disability can't count to 5. Can't count to 5. And if 88% of elementary students who take the alternate assessment can't even count to five, then clearly there is a need for more effective math instruction for students with moderate and severe developmental disabilities, which is why you're here in this class. This is what this class is all about. Because we can impact this. You have the power to change this. And that's why I find this part of the semester so exciting because it is. It feels like we're like superheroes or something. All right, so let's go ahead and stop really quickly. Do a self-assessment. Where are you in front of as far as your understanding goes? If you have any questions, make sure you write them down because questions are important and we welcome questions because that is a way for us to grow. And it is true that if you have a question, somebody else probably has it too. All right, I'll see you in the next video where we'll really start jumping into early numeracy.